The distribution of quantitative variables are building blocks for histograms. Histograms plot the bin counts as the heights of bars.
Bar charts of categorical variables have spaces between the bars to separate counts of different categories. In histograms, bins separate all the values of the quantitative values, so spaces are actually gaps that indicate regions with no value.
Stem and leaf plots are like histograms and are useful in the making of them. When describing data, you should always check for the shape, center, and spread.
Humps in a histogram are modes. Histograms with one peak are unimodal. Histograms with two peaks are bimodal.
Histograms with more than two modes are multimodal. Histograms that do not appear to have any modes and in which all the bars appear to have the same height are uniform.
If the distribution's tail stretches out farther than the other, then the histogram is skewed. One should notice any outliers that stand off away from the rest of the distribution. Gaps in the distribution helps notice multiple modes.
So I'm going to show you an example of how to make a histogram. This is a collection of numbers that are basically our values. In a histogram, the y-axis would basically be the frequency of the numbers, and then the x-axis would be where our values would go. So since there are different values in our numbers in our bins, we would go from 7 to 13. 13. And that's basically our x-axis, what our values. For our y-axis, that would basically be the frequency of our values, like how many values are in our bins. Like for example, there's 3 7s, and then there's like 5 8s. So we would at least put our values to where where it's going to 5. Alright, so since there are 3 7s, we basically draw a bar going to 3. For 8, we would go to 5, 9 is 1, and it's basically just the same thing for all the other ones. For 10, there's 2, 11, there's 1 also, 12 is 3, and lastly, 13 is 1. And that's basically a histogram.